How can we reduce costs, develop faster and more cost efficient? Come with me, I will show you quickly something. My name is Romano Roth and I'm the Chief of Cybernetic Transformation and a partner at Zühlke. I work for Zühlke now since 23 years. I joined Zühlke directly after university as a junior .NET engineer, became then an expert software engineer, then an architect, and finally a consultant. And one thing that was always close to my heart is how can we automate things? How can we ensure the quality of what we are building? How can we build the technology foundation, and how can we transform whole organizations across the value stream so that we can continuously deliver value? And when the whole AI, platform engineering, Agile and DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing in Zurich with over 2,500 subscribers. I'm also one of the organizers of the DevOps Days Zurich, which is a yearly 2-day conference we are doing. These DevOps Days, they are all around the world in all of the big cities, and I'm the president of the DevOps Days Zurich. Now you can see these topics, they lie very close to my heart. This is also why I have my own YouTube channel, which you are watching right now. And with over 250 videos, I also post and tweet a lot. And if you want to learn more about these topics, then please follow me on one of these channels. I'm also currently writing my own book about the Cybernetic Enterprise, which I will release roughly in August. And I'm also a lecturer at the HSLU for digital transformation, for enterprise architecture, and also for DevOps. And of course, I also work in client projects with different clients in different industries, doing Agile, DevOps, and architecture. And currently, I'm also the product manager of one of the platforms that we are building at Zühlke, our own platform plane. So now I have a question for you. What do you think? What is the percentage of features in the average software product that are rarely or never used? I give you a quick moment for that. The answer to that is 80% of the features in an average software product are rarely or never used. There are different studies out there. This is sort of one of the latest, but all of them come to the same number. So 80% of the average software products, of the features in an average software product are rarely or never used. Quite a large number. Now, what do you think? What is the percentage of the total software lifecycle of the costs which is typically attributed to maintenance activities? So when we have, for example, a feature that costed us $100, how much do we need to invest over the whole life cycle? Again, on top of that, what could be that percentage? Is it again $100 for the whole feature, for the whole life cycle, or is it less or even more? What do you think? The answer there is not that clear. There are different studies out there. We can say roughly between 40 to 80% is what we need to invest on top of that. Of course, this is heavily dependent on how good your software engineering skills are. I mean, if you are implementing quite a lot of technical depth, then this number will rise massively. So when we look at that, then we can say, okay, on one hand, 80% of the features that we are building is rarely or never used. And on the other side, the maintenance cost of these features over the whole life cycle are again an additional 40 to 80%. Now, when we roll that up with a small calculation, a rule of thumb calculation in Switzerland, we say them Milchbüchli-Rechnung. we can say the following. So when we develop, let's assume we are developing 10 features. Cost per feature is 100,000 Swiss francs. Now the total development cost is around 1 million Swiss francs, and the maintenance costs for that is, because of the 40 to 80%, is roughly an additional 400,000 to 800,000. So this leaves us with a total cost for these features over the whole life cycle of 1.4 million to 1.8 million. This is how much these features will cost us in the end. This is also quite an important number, just to say. Now we could eliminate now these 80% of these features which are rarely used, and then we would have a potential saving in development cost of roughly 800,000, and the potential savings in maintenance cost would roughly be 320,000 or 640,000 Swiss francs, which is a total saving of roughly 1.1 million or 1.4 million that we can do around that. And of course, this is just a rule of thumb calculation, but you already can see how much costs you can save when you build the thing right and when you build the right thing. And these are two very important concepts when it comes to saving costs. Now, there is a saying from Dr. Russell Ackoff, which is, doing the wrong thing right is not nearly as good as doing the right thing wrong. So first of all, building the right thing is all about how we align our solution to the business and to the user needs especially. So only in the user uses that feature or can use the feature, then it's a useful feature. And of course, this is only true if we have understood the problem or the need of the user. And of course, we also need to have a common understanding of this problem. This is all about effectiveness. On the other hand, we have building the thing right. This is all about how efficient is our engineering practices, how fast can we deliver changes, how easy and fast can we change and adapt. This is all about efficiency. So this presentation here is all about this efficiency topic. I have other presentations on my YouTube channel, which are linked in the comments, about building the right thing, which is also an important topic, but this presentation focuses solely on that part. So when we look at the modern software development, then this is a continuous process across that value stream that you see there in this infinitive symbol, which we are quite often use in DevOps. And you also can see all of the practices. Now, the important thing about that, it is a value stream. It is a never-ending value stream. It's not a project which starts and ends. It goes on and on. And this is also the key message to you. Modern software development is product development. It never stops until you decommission your software, which unfortunately quite rarely happens. Now, a value stream is nothing else than a sequence of work. It is step 1, then step 2, then step 3. And it usually has a trigger where we have step 1, 2, 3, and then in the end we have value. And we are continuously doing that. For example, we have a feature request, then 1, 2, 3 happens, and then this feature goes to the customer and generates value. Now, when we look at value stream mapping, then we do the value stream mapping because we want to understand how value flows through the system so that we can identify the bottlenecks of this system and that we can continuously improve. We have then a visualization and a common understanding of how value flows through our system. And that's a very, very important thing to have. Now, how do you do that? It's quite simple. You gather all of the people that work on a value stream. You bring them together, either in a room, that would be awesome, or into a virtual room with a Miro board, for example. And then you say, what are the steps that are needed from ideation until production? Here we have a small example: feature definition, design, then we code, then we test that system, then the PM accepts this feature, then we deploy to staging environment, we do some smoke testing. After that, we do quality assurance in that smoke test environment. Then we are deploying to production, then we're doing some smoke tests in production, then we do again some quality assurance in production, and then we get the production sign-off. This is just a very small example. Your value stream looks completely different, just as a small example. After that, what we are doing is we identify the people who are working on these different steps. And this gives us already quite an interesting view, because now we can see the handoffs between the people. For example, feature definition is done by the PM, then we have the design done by the architecture, coding done by the devs, testing done by the testers. So here we see already where we have some handoffs. Now we say, okay, and now we want to measure the performance of each one of these steps. For that, we use PT, which is the process time. The process time is the time where we really are doing value-added work. Feature definition, the PM works on the feature definition for, in that case, 4 hours. The lead time is the time from starting the feature definition until the end. You see, it's 48 hours. This is 2 days. So in average, the product manager works for 2 days on the feature definition, but he only needs 4 hours. It can be that he works 1 hour on one day and then the rest of the 3 hours on the other day. And that's an important thing, because now we also see where we have a potential error in the system where we do other stuff potentially. We also have the percentage complete and accuracy of roughly 80%. This is just a percentage C and A down there. And that means that usually the quality is good, but in 20% of the cases, we need to go back to that step because the feature definition was not that clear, and we need to ask the PM for clarification. So 100% would be, we never need to go back to the feature definition. The feature definition is perfect, always perfect, then it's 100%. And now you can do that for all of these steps, and you can then sum up the PTs to the total PT, which is in this case 161 hours. You can sum up the LTs, the lead time, you get 2,160 hours, and you can see there is a slight gap. Now when you divide that, you get the activity ratio, which is 7%. Now you know that in 93% of the time we are not doing value-added work in the whole lead time, which means, of course, there is the night and nothing happens there. Now, to bring that up, you can invest into automation, into AI. Exactly. Now you see these are the efficiency gains that are potentially in there. And of course, you need to use your brain, if it makes sense, to raise that bar, of course. The rolled percentage complete and accuracy looks at the quality of these steps, and now you can see it's 5%, which means in 95% of the time we need to rework, which means that we need more than the average 2,160 hours to bring a feature into production. Also here we could think of, can we use AI to raise that, or automation, or also process new processes? Well, we just need to use our brain. Now, the interesting thing is, now, first of all, we have a clear picture, an agreed picture on the whole group about how value flows through that system, but we also see where the bottlenecks are. And these are the areas where we can invest our brain time to improve that, because with that we can first of all improve the lead time so that value flows faster through the system. Faster value through the system means more features delivered, and with that more value generated faster. And we can also concentrate on the percentage complete and accuracy, because that means quite a lot of distraction due to errors, unclear things. If we can raise that, that would be also quite awesome. And again, that would speed up the whole process because we don't have any rework. So you see, quite an awesome thing. Now, what you're then not doing in the fifth step is you think about how could the perfect value stream look like. And you can see I created a completely new one out of my mind, how that could look like. First, I say we do a story refinement together. Then we do the sprint planning. We do the story kickoff. We code. We do always a code review. We do automated testing, automated deployment to staging, automated testing in staging, manual testing in staging. Then we trigger an automated deployment to prod, automated testing in prod, and automated product sign-off. And you can see the numbers are now much better. We have a total process time of 16.4 hours per feature and a total lead time of 147 hours. The activity ratio has now raised to 11% and the rolled percentage complete and accuracy is 72%. When we compare that, this is very, very good, quite improved. I'm pretty sure we can do even better. It's just sort of the first step, our guiding North Star. In this direction we could go in a first step. Now, when we have that clear picture, now we can use our brain and think about how can we improve. Of course, one of the obvious things is process. We can streamline the workflows, eliminate the waste and standardize procedures. That's always a good thing. Now we can also leverage automation and AI. Yes, we can use modern tooling in there, infrastructure as code, all of the fancy stuff. And of course, we also can now think about organizational structure. You saw the different handoffs. Now we need to think, okay, can we rearrange the teams better so that we have less handoffs? Can we organize them more across the value stream? And of course, also governance, very important. Usually you have quite large governance bodies in there, and this can also lead to some slowdown, which you can also automate or eliminate. As you can see, with this technique, you can also identify where to use AI, and with that, AI is no longer guessworking like, yeah, we could use AI there and potentially it will get better. Now you really can see where AI could fit, and you have the numbers and data and facts that you can also verify if it had the right impact. And that's a really awesome instrument which I can highly recommend to you to use in your organization. Sort of that was now, let's say, the thing that you can immediately do to reduce costs and analyze your whole value stream and optimize. Now, on top of that, you could see that, of course, also many things are not only process related, many things are also technology related. And for that, I must also say that such a value stream needs to have the right foundation, the right technology foundation. And as I always say, we are at the moment entering the age of industrialized digital product development, where you can see at the moment many things or many products are developed in a custom manner with internal, with external teams or with mixed teams, and they are always sort of reinventing their wheel, do it their way, which leads to quite a heterogeneous system landscape. You using quite a lot of tools, huge tool landscape, huge methodology landscape. This leads usually to high complexity and to a high cognitive load. Where the industry is moving into the direction of building platforms and standardizing how products are built within an enterprise with a clear set of services and products to be used to create these products. Now, when we look at the target operating model of a so-called cybernetic enterprise that we are building with, that is, we have multiple autonomous teams with quite a large technology stack where the complexity is high, the cognitive overload is quite high, and where we are moving is into a target operating model where teams are working on their own product, creating features, focusing on the features, on the business value, on the customer. And of course, this can be a product. It can also, of course, be a module of a larger product. You see also that the technology stack is much smaller. Why? Because below we have the technology foundation, which covers your value stream, which has the large part of the technology stack in there, where you have a platform team that creates a self-service platform. Let's dive into that. This platform team creates your cybernetic platform, which is a self-service portal, which has all of the tools that your product teams need to develop their products for their customer. It also has all of the capabilities that the product teams need to develop their products. The product team, they focus on the development of the products, and they do it end to end, which means you build it and you run it. The platform team creates that internal product. It's very important. It's your product. And in your case, this cybernetic platform can look different. It can have other tools. It can have other capabilities. It heavily depends on your product teams, what the product teams needs, because they are the customers of your cybernetic platform. I give you an example, which is always important. For example, observability. We have the capability of observability over the cybernetic platform. We are exposing or delivering observability to the product teams, which can be, for example, Grafana with predefined dashboards, all of that. But The monitoring is done by the product teams because they are end-to-end responsible for their product. And with that, you can see the platform teams generate value for the teams and the product teams generate value for the customers. Okay, now you say, okay, Romano, we got the theory, but does that work in practice? And of course, also at Zühlke, Zühlke is a cybernetic enterprise, and we have our own cybernetic platform, which we use for our internal projects. We use that for our customer projects. So all the time when a customer does not have such a platform, then we use that because it massively accelerates how we deliver products to our customers, or we use it completely and we give that to the customer, so to build based on our cybernetic platform their own cybernetic platform, or we use parts of it to create their platform, or we use it as a blueprint for creating their own platform. On the top level, you see all of the people that are working with such a platform. They have access to a CLI, they have access to the internal developer portal. You can see that we have done domain-driven design. We identified the different bounded boxes, and below we have then the provisioning and automation layer. This is always an important thing because many think it's an internal developer portal and that's sort of backstage. That will be only the top layer. As you can see, there is much more below, and many customers are massively struggling with the provisioning and automation, especially when they have different cloud providers and also on-prem. Below that, we have the unified integration blocks where we integrate all of the tools over adapters and connectors. And here is again another very important thing about the integrated tools. Here we are not integrating the tools together, we are always integrating that over the platform, because it might be in the future that you would like to get rid of one of the tools. For example, GitLab. I love GitLab, it's quite awesome, but GitLab is also a company which is on the stock market. Investors are investing, they are making minus 50 million every quarter, and the CEO, there are rumors that he would like to sell the company, and of course that's completely okay. If, for example, Google buys that company, then it's thumbs up. If Broadcom buys the company, then you might want to get rid of that tool very fast. And this is why it's so important that you integrate that over your cybernetic platform. As said, we are using that very successfully at the moment at Zühlke, and I will also quickly show you that. The core concept behind that is the concept of the so-called floating platform principle, which is from Gregor Hoppe out of the book Platform Strategy. Absolutely must-read book, where you are going to integrate all of the tools, all of the DevOps platforms and the cloud providers into your platform so that you can standardize all of the processes and all of the tool usage over that platform. The important thing is don't duplicate any of the features of the integrated tools, because with that your platform gets heavily dependent and then it begins to sink. So many of you will now say, hey, but Romano, where is AI in that picture? AI is usually everywhere. Now, AI is just that box down there. It is a capability of your platform. With that capability, you are providing to the company, to the whole company, AI as a service, but also to your product teams. And that's a very important thing. And in some minutes, I will show you how we are doing that at Zühlke. Now, some of you might say, hey, this is quite a small box, But when we enlarge that box, then you can see that it's quite huge. And now you also get a glimpse on the extent of such platform and why they are the fundament of, or the foundation of your cybernetic enterprise. It has usually an application layer where you have, for example, chatbot applications, which I will quickly show you in a minute, synthetic test data, AI coding assistance, knowledge management things. You have a tool layer where you provide to your product teams prompt engineering, vector databases, or a golden path solution for RAG solutions, or you have then below the model hubs where you have different models in there, and below you have the GenAI infrastructure where you are integrating either on demand or then directly cloud providers. Now let's have a quick look how our own cybernetic delivery platform at Zühlke looks like and what we have already built with that. So with that, what you see here is the cybernetic delivery platform of Zühlke that we use internally to build our internal products, and especially nowadays the AI products for us internally, but of course also we use it for products that we build for our customers. So every time a customer does not have its own development platform, then we use our own cybernetic delivery platform, which you can see here. But as I also said, we use that also as a blueprint for platform development with our customers, but we of course also use it for or we use parts of it for developing platforms for our customer, or as a whole we also use that for our customers. So with that, let's go quickly into the administration area. In the administration area, we see that currently 465 users are using our cybernetic delivery platform. 15 partners, 26 spaces are created, and 12 Kubernetes clusters are working within our platform at the moment. I will come to partners and spaces in a minute. Here, down here, you see the platform costs, because we of course track the costs per space that we have. One of the important concepts that we have is the partner concept. Here you see the different partners. The concept behind that is we are working with different clients, and of course also those companies that are also using our platform, they are also working with different vendors, for example, and then you want to onboard them. So here what we can do is add a partner, and a partner is nothing else than an organizational unit. It has a domain, and then this domain will be integrated. We are using Azure Entra ID for doing that. With Azure Entra, we can onboard another company. They can bring their own identity, and with that, they can use our platform. Here, the important thing is you remember the concept of the floating platform, all of the tools that are integrated in the platform, and of course of the spaces. And this means we can onboard someone within a second, and in that second, this person gets access to all of the tools and to the assigned space in the platform. And of course, you can also then offboard someone within a second from that platform. With that, we are going into the spaces. A space is nothing else than a network zone. We are using the hub-spoke network concept here, where each one of the spaces is a network zone, and with that, in that zone, a team can do whatever they like. They can have a virtual machine in there or multiple virtual machines. They can have a Kubernetes cluster in there. They can have multiple projects, products in a space, or just one. We don't care. And with that, we also make sure that these spaces are separated from each other and that nothing bad happens. With that, we are going to the main page where we can see the different projects which I have access to. I go into the platform space where this platform is built. Here I see what kind of tools are in use where I have access from this space. I can go to repositories where I see the repositories. I can click on one of these repositories and via single sign-on I'm logged in, so I don't need another credential. Now here I can click on that shield, and now what we see here is the vulnerabilities. Now the interesting thing is, as you recognize, we integrate all of the tools and of course also the spaces into this platform, which means we have access to the source code, and this means over the platform we can now ensure security. So this is the whole DevOps thing. What we are doing here is we are doing SAST scanning, we are doing license compliance scanning, and we are doing secret scanning directly over that. Of course, our users can still work with the pipeline and also ensure that over the pipeline. This is absolutely okay, but the platform itself also ensures that. We can create a new repository, we can create a blank repository, but we can also create one from a template. And this is also a very important concept. These are the so-called golden path solutions. At our customers, we have much more of these golden paths, including golden paths where even the infrastructure is created over GitOps. And here at Zühlke, we of course are very, very broad when it comes to projects, so you only have some test templates in there. But this is also a very important concept when it comes to industrialization and standardization, which you would like to have. We can then click on the images where we have the different images. We can go to one of these images. We see the different version of the container image, and again here we also have the container scanning directly included. I can click on layers. Now see the layering, and then I can click on Analyze AI, and this is what you can see. Here we are integrating directly this AI capability that I was talking about directly into the platform, and with this capability we can scan the images of one of the projects. This is of course very helpful for our employees. We also have the default packages like Maven, NuGet, and npm, which we can also support. And then we have the platform itself. Here we have the Kubernetes cluster. So normally when we can decide, we go for container and then for the Kubernetes cluster, because this gives us the biggest flexibility, and it also enables us to really go deep into the customer wishes, what the customer wants. We have here the different applications. For example, here a chat application. We see the public endpoint. We see directly the Kubernetes objects. We see the application violations also in here. And we can, of course, also, when we have that, when we deploy such an application, we are always going over a GitOps approach. This is sort of our default approach, how we would like to work. Of course, you can also go a different approach, but because of that, we also have integrated Argo CD, which you can see here, which is of course also directly integrated into the platform. And with open logs, we can have a look at the log files. And this is exactly what I told you, that Everything is integrated. I, as a developer, I don't need to care anymore about logging. What I do is I create my repository, and from there the image will be deployed into the image registry, and from there via Argo CD I can deploy it into the Kubernetes cluster. And I don't need to care anymore about logging. Everything that I log out to standard out will be automatically available in here. I can also, I have also access to different tools and different plugins. Here, the Tempo plugin, where I see my microservice structure. I have also access to different dashboards that are default already for me provided in here. And of course, I can also analyze the log files in here. Again, this is a convenient thing that I can do, so that I don't need to copy paste log files. It's already integrated, and at the moment we are working on more and more AI features to support our development team. That said, we have here the service catalog where the developers can choose services, like for example, when they need a MongoDB, they can click on that, and then this MongoDB is provided in a, of course, default setting, but they don't need to care anymore about versioning. They don't need to care anymore about a username, password. Everything is provided directly out of the box. The default is templating over infrastructure as code, because that's our approach, but of course they could also do GitOps. They could also create it directly. That's of course also a possibility, but we always recommend the GitOps approach. Now the interesting thing is that thing here, the Azure OpenAI. Here we are providing standardized and governed the API to our AI. And based on that, development teams can build on top of that. And this is, of course, something that we did. Here you can see our own chat application that we have in Zühlke that we use. And this chat application uses that interface that you just saw, which then goes over the platform as I demoed it. We also have here the ZenAI. ZenAI is also one of our applications that we have. It has some default prompts that are already created for us, and of course also some RAG capability. This is something that we can also use directly as a reusable asset for our customers. We have our reference finder. Here I cannot make a demo of it because here are our projects. We have done 10,000s of projects, and to get a sort of an overview about all of these projects is difficult. And here you can find references, project references for the offers that we are creating. And here we have the Zühlke AI Skills baseline, where we provide all of the education material in the AI area and also some sample applications. With that, I want to show you one last thing. You see, we have more stuff to show, but in regards to timing, I will not show that. Here we then see the costs for the platform. We can also add here some roles and then also some members. This is important, these costs, that we can give these costs to the different projects, because the projects are then charged for exactly that. And with that, at the end of the presentation, let's head back to the slides. As you can see, we are clearly moving away from an enterprise where all of the services were just put there, where you needed to create ticket for everything. So where the people were doing ticket ops, into a direction where you have the right foundation for your cybernetic enterprise, where you can just grab the services that you need for your customers directly out of a fully automated shelf powered by AI, where you can grab either services that you need to use or where you can create your own factory out of the box. And this is really where we are heading, into the direction of having a cybernetic enterprise, which is continuously evolving, self-regulated systems that learns through feedback loops, that adapts itself, and where humans and AI are working together. And with that, when we are looking at how to build such a cybernetic enterprise, then it's of course very important that we understand our value streams. This is especially important if we want to improve, if we want to save money, if we want to deliver faster. We need to understand our own value stream. As I showed you, it is a very simple technique. First, identify all of the steps from ideation until production. Then identify the people who are working there. Third, identify the numbers, process time, lead time, percentage complete and accuracy. Then calculate these numbers, see where the bottlenecks are, think about them, and create your future value stream. Such a value stream needs, of course, the right foundation. This is done over platform engineering, where you create your own floating cybernetic platform, where AI is a service, as you could see, and this is how you build your cybernetic enterprise. And as you can see, the future belongs really to those who master the symphony between organization, process, technology, and governance, and of course, AI. And this is the way how you can reduce costs by continuously delivering value. Thank you very much.